Okay, so the chapter is haloalkanes and haloarenes. Okay, so what are haloalkanes and haloarenes? It means just simple. That is any alkyl group or any aryl group. Okay, alkyl group or any aryl group attached to a halogen atom. Attached to an halogen atom. Okay, this is called as a, if it is attached to an alkyl group, then it is called as a haloalkanes. If it is attached to an aryl group, it is called as haloarenes. Okay, so how do you bring out alkyl group? Okay, generally you will find a alkane group. Okay, so you find a like alkane group. Okay, so if you remove one hydrogen atom from this, okay, if you remove one hydrogen atom from this, then you will get a alkyl group. Okay, then you will get a alkyl group. Okay, so for this alkyl group, if you attach, okay, halogen atom, attach the halogen atom, okay, if you attach the halogen atom, then you will get a alkyl group. Okay, the same way you will get a aryl also. Okay, just removal of a one hydrogen atom and replacing that hydrogen atom with a halogen atom. Okay, that gives you an alkyl group. Okay, it's a simple thing. Okay, so like why we need to study this thing? Okay, what is the reason to study this thing? Okay, so generally for many treatments, okay, many treatments, we use the basic thing, or we use this haloalkanes. Okay, we use this haloalkanes, or it can be haloarenes. Okay, haloarenes as a basic thing. Okay, generally for the treatment of a typhoid. Okay, for the treatment of a typhoid, we use this haloalkanes as a material. Okay, that is the, which is the antibiotics called as a chloramphenicol. Okay, chloramphenicol is antibiotic, is used to treat a typhoid. This antibiotic is made from this haloalkanes itself. Okay, this is made from a haloalkanes and haloarenes itself. Okay, so why we need to study this haloalkanes haloarenes is that we need to synthesis this. Okay, we need to synthesis some antibiotics with help of this thing. Okay, so this is the main reason why we need to study. And there is some other thing also, like synthesis of, like if you synthesis a chloroquine, chloroquine. Okay, it is used as treatment for malaria. Okay, it is used in treatment of malaria. Okay, which is this compound? This is a compound of a haloarenes. Okay, it's a compound of haloarene. Okay, so why we need to study? This is the main reason why we need to study the haloalkanes and haloarenes chapter. Okay, so you know typhoid, it's a major disease. Okay, so typhoid can be cured with the help of this haloalkanes or haloarenes. Okay, which is that antibiotic used? The antibiotic used is a chloramphenicol. Okay, so the malaria is also a big disease, right? So this disease can also be cured with the help of a chloroquine. Okay, it's a antibiotic. Okay, this is made up of a haloarenes. Okay, so these are the different type of examples or antibiotics from which, from these are derived, like which have been derived through a haloalkanes. Okay, so I think you got the application of this. Okay, these are the applications. So why we need to study this type of compounds? Why we need to study the haloalkanes and the haloarenes? Okay, so fine. So now let me, like last class I was just classifying the, okay, so classifying the compounds. Okay, so on the base first type, there's a classification of this haloalkanes and haloarenes based on their halogen atom. Okay, based on the halogen atom attached. Halogen atom attached. Okay, so I'll just sum up faster. Okay, so halogen atom is attached. If one halogen atom is attached, okay, if there is a only one halogen atom is attached to an alkyl or aryl group, okay, that is called as a mono alkane, or we can call it as a mono halo alkane. Okay, we can call it as a mono halo alkane. Okay, we can call it as a mono halo alkane for an alkyl groups. Okay, and you can call it as a mono halo arenes. Okay, for an aryl groups. Okay, for an aryl groups, you can call it as a mono halo. Okay, so what are the example for this? Okay, so it should contain only one halogen atom. Okay, if it contains only one halogen atom, then that is called as a mono haloalkanes or mono haloarenes. Okay, so example, you can take this simple, you can take a methyl. Okay, you take a methane first. Okay, you can take a methane, just remove one hydrogen atom and replace that with one chlorine atom. Okay, or any halogen atom. Okay, so I'll just represent the X as a halogen atom. Okay, so X can be like fluorine, chlorines, bromines, and iodines. Okay, it can be anything. Like anything means to be like fluorine, chlorine, bromine, and iodine itself. Okay, so you take a methane first, replace one hydrogen atom with a chlorine atom. Okay, or I'll replace it as a with a X. Okay, with a X. Okay, then it gives you a generally CH3. And if you talk with the haloarenes, just take any aromatic group. Okay, just take aromatic group. I'll take a benzene here. Okay, so benzene, like if you write the ring inside that, nothing is the issue. Okay, just replace one hydrogen atom of this any one. Okay, so add halogen, it gives you a aryl benzene. Okay, it gives you aryl. Okay, so the next thing we just do with this is the next part is if the contains a two halogen atom. Okay, if it contains two halogen atoms. Okay, if it contains a two halogen atoms, then what will be that? Okay, so those are called as a di alkanes, or it can be called as a dihaloarenes. Okay, what is the example of dihaloalkanes? Dihaloalkanes will be like you can take for dihaloalkanes you can't take this thing, right? Because like dihaloalkanes, okay, for same like you should not attach the halogen atom to the same carbon atom. You should attach to a different carbon atom. Okay, so if it attach to a different carbon atoms like this, Cl and Cl, H2, H2. Okay, you have a dihalogen, okay, dihaloalkanes. Okay, next with the dihaloarenes, like you can take any benzene, attach a two halogen atom to this. Okay, then it is called dihaloalkanes. Okay, the next you can take a third one. Third, you can take a trihaloalkanes, trihaloalkane, or you can take a trihaloarenes. Okay, so okay, example of this you can take this three carbon atoms attached to X, attached to X, attached to X. So satisfy the carbon valencies now. Okay, generally what carbon should make a four bonds, right? If one is made with a one carbon and one more with a halogen, so only two bonds is remaining in this first carbon atom. In a second carbon atoms, two is already made through a carbon and a one is made through halogen. So still one is left that will be satisfied with a hydrogen here with the two atoms. Okay, this is a trihaloalkanes, and next is the trihaloarenes. Okay, so X, X, X. Okay, so I think you understood this thing. Okay, next classification on the base of the next classification on the basis of the, like let me take a B, like second classification on the base of a compounds containing six bond hybridization. Okay, I think you won't get through the sentence. Okay, so let me tell like first thing, compounds containing with the, see, this CX bond is sp3 hybridized. It is a first classification. Okay, if CX bond is sp3 hybridized. Okay, this is the first classification. So there you can talk now with the like carbon, hydrogen, 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 and X. This is a one. This is also one. You can classify through this hydrogen, hydrogen, hydrogen. Or let me take the R group. It will be easy for you next to understand. Okay, so R group, like R group means normally R can be any group. Okay, so it can be a CH3, it can be any hydrocarbons. Okay, you can just take a hydrocarbons. Okay. Next is the halogen, and same thing, 6 hydrogen, and this two hydrogens are replaced by the R groups. Okay, so R groups and X, and one more that is replaced by the, so sorry, replaced with the R group and R group and R group and X. Okay, so this all carbons are sp3 hybridized, right? Is there any difference? Is there any doubt for you that this carbon is not sp3 hybridized? Is there any doubt? No, right? Every carbon here is sp3 hybridized. You can see the bonds here. Okay, all are single bonds. 1, 2, 3, 4, 4 bonds. Like if it is a 4 bonds, it's sp3 hybridized. Okay, this carbon is also sp3 hybridized. Every carbons are all sp3 hybridized. Okay, that's common. Okay, now I'll come for different classification. That is, if if for this carbon halogen bond, okay, for this where the carbon has made the bond with the halogen, if for that carbon atom, if you replace one hydrogen atom with the R group, okay, then that group is called as a primary, okay, that group is called as a, like a, let me write it, it's called primary alkyl group, primary haloalkyl group, okay, primary or alkyl halogen, okay, so you can write it as a primary haloalkyl, okay, you can write in this way, okay. If a two hydrogens are replaced by the diff two R groups, okay, then it is called as a secondary, okay, then it is called as a secondary group, okay, it is called as secondary, okay. If all three hydrogens, like 1 2 3, all three hydrogens are replaced by the R groups, okay, by the R groups, then it is called as a tertiary, okay, then it is called as a tertiary group, okay, tertiary haloalkyl groups, okay, or tertiary haloalkanes, okay, you can write a tertiary haloalkanes. Okay, I think you understood this. Next, this is one type of classification, and one more you can go with the classification of a allylic halides. Okay, there is a one more type, that is a, there are different compounds. Okay, allylic halides. I'd say what is allylic halides? Allylic halides means it is also same carbon with the halogen. This carbon will be the sp3 hybridized, but this carbon is bonded to the next carbon containing a carbon-carbon double bond. Okay, so this carbon is sp3 hybridized itself. You can see the sp3 hybridization. Okay, you can see the sp3 hybridization here. Okay, but the next to this carbon is a sp2 hybridized. The next carbon is sp2 hybridized. Okay, if I write generally, like double bond and this carbon, and this is attached to halogen. Okay, now this is a, okay, now this is sp3 itself, right? This is sp3 itself, but the second carbon, okay, the second carbon, you can call it as a alpha. Okay, this alpha is a sp2 hybridized. Okay, this is called as a allylic halides. Okay, this is called as a allylic halides. Okay, it is also present in a cycloalkenes also, cycloalkenes, like a cycloalkene, and this attached to a CH2 halogen. Okay, this is also called as a allylic halides itself. Okay, this is also example of an allylic halides. Allylic halides. Next we'll talk about the benzylic halides. Okay, next I'll talk about the benzylic halides. Benzylic halides means same thing. Here we'll talk with the benzene group attached to a carbon containing sp3 hybridized. For that sp3 hybridized, halogen is attached. Okay, you can see here that is a benzylic. Okay, so benzylic halides you can write. So this is a benzene attached to a carbon. This carbon is sp3 hybridized. Okay, this carbon is sp3 hybridized, and okay, so hydrogen. Okay, this carbon is sp3 hybridized. It is a purely sp3 hybridized, no doubt in this. Okay, so this type of classification is called as a benzylic halides. Okay, so done. So this all comes under the sp3 hybridized compounds. Okay, so first is sp3 hybridized. Next, that is a sp3 hybridized attached to a, so carbon containing double bonds. Next, sp3 hybridized attached to a benzene group. Okay, next we'll talk with the halogen. Next we'll talk with the halogen attached to sp2 hybridized carbon atom. Okay, sp2 hybridized carbon atom. Halogen attached to sp2 hybridized carbon atom. Okay, so what is this case? Okay, if you talk about this is a different case. Okay, so what is this? Then this will classify again with the two types. Okay, one is the vinylic halides. Okay, one is the vinylic halides. That is, you know what is vinylic? If any substituents, okay, if any, like not only with halides, okay, not only with the halides, you can take any things. Okay, if it is alcohols also, okay, if it is attached to a, if any alcohols or halides, any substituents attached to a carbon-carbon double bond, okay, those are called as vinylic substituents. Okay, this OH or we can take it as a halogen. Okay, right, it's a halogen. Okay, it's a haloalkanes. I like the haloalkanes itself. Okay, in the alcohols we'll just study again about this. Okay, so X satisfy the valency of carbon. Okay, so this type, okay, this type is nothing but a vinylic halides. Okay, so if like okay, this type is nothing but a vinylic halides. Okay, so if it attached to two things, then it's a vinylic dihalide. Okay, now it is a vinylic monohalide. Vinylic monohalide. So the same thing, you can go with alkene also, like cycloalkenes, double bond. If it is attached in this way, this is a sp3 hybridized. Okay, this is a different classification. Okay, this is a classification of allylic halides. Okay, if this halogen atom directly attached to this carbon-carbon double bond, then it is called as a vinylic halide. Okay, then it is called as the vinylic halide. Okay, this is the vinylic. Okay. So this is called as a vinylic halides. Okay. The next thing is we come with the next thing we talk with the it is the aryl halides. It will be the aryl halides. Here directly halogen group halogen atom is attached to benzene ring, or like I won't mention the benzene ring here because like maybe benzene substituents also are aryl groups. Okay, attached to a aryl group. Okay, so for aryl compounds, this halogen atom is attached by replacing a one hydrogen atom. Okay, so that will be this case. Okay, I think you got this. Okay, look here. This is sp3 hybridized carbon. This is sp3 hybridized carbon. So this halogen atom, sorry, sp2 hybridized carbon. This halogen atom is directly attached to a carbon which is sp2 hybridized. Okay, and that compound is also a aryl compound. Okay, as mentioned, this is not a simple vinylic halide. Okay, it is an aryl halide. Okay, this is an aryl halide. Okay, in a vinylic halide, what happens? The compound will be alkyl. Okay, the compound will be, this compound is an alkyl compound, but that is double bond. Okay, that is double bond, that is sp2 hybridized. Okay, so fine, I hope you got these things. Okay, so next I'll go for the nomenclature. Okay, nomenclature of the compounds. So nomenclature. So like for nomenclature, the basic rule is everyone should follow this rule compulsorily. This is a basic rule. Okay, like if you follow this rule, everything will be easy. Okay, so now you have to just go find with the number of carbon atoms. Okay, if you find the carbon atoms, start to label that carbon atoms. Okay, like 1 2 3 4. Okay, always you have to choose the lowest locant. Okay, you have to choose the lowest locant, that is lowest number for which a carbon substituted. Okay, now first we have to go with the word root. Okay, so what is the word root? What is the number of carbon atom present in that compound? Okay, first you follow word root. After this word root, you have to go with the suffix. Okay, you have to go with the suffix. That will be a primary suffix. Okay, which will be the primary suffix? That is, it can be a ane. Okay, it can be a ane. That is for alkanes. For alkanes, it will be ane. For alkenes, it will be ene. For alkynes, it will be yne. Okay, next go for the secondary suffix. Secondary suffix, if you talk about secondary suffix, that will be your functional group. Okay, it will be a functional group. Like for an alcohols, it will be OL, for an aldehyde, it will be AL, and for acids, it will be oic acid, for a ketone, it will be ONE. Okay, this is a next. We have to go for see the primary prefix. The prefix is what comes first, right? Yeah, the prefix andre, the one which comes first. Okay, word root kinta munche baro, that is called a prefix. Okay, so that will be a cycle. Okay, it's always a cycle. It's always compulsory cycle. Okay. Next, we'll talk about the secondary prefix. That will be your any substituents. That will be your any substituent. Under this, you will get under this will be a halogen group. Okay, under this you will substitute with the halogen groups. Okay, so in this halogen group is considered as a substituents. Okay, substituents. You have to find the word root first, then find any suffix is there or not. Then you can see the cyclo, and then you can see the halogen group, which halogen group is. Okay, before doing this, we have to see the lowest locant. Okay, this lowest locant is compulsory for everything. Okay, fine. So now I'll give you some 3-4 examples, okay, like because it will be very easy if you do with some 3-4 examples. So first you can do with the CH3, 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 CH2, CH. Okay. So now what I told you, first go with the labeling. Okay, that labeling or numbering a locant or numbering the carbon atoms, it should be completely lowest. Okay, that means the long chain you have to choose will be the larger one. Okay, but I'm talking about the substituents. Substituents should get a lowest locant. Okay, see the longest carbon atom. So if it is a 1, 2, 3 or 1, 2, 3 or 1, 2, 3, everywhere it is completely 3 carbon atoms. Okay, it comes with a 3 carbon atoms. 3 carbon atoms. Okay, so no need to worry in this case. Okay, so this and this are considered a substituents. Okay, so at a second position 2,2, this is a 2,2, it is a dimethyl groups, right? Those are called as a methyl groups. Okay, CH3, what is CH4? CH4 is called as a methane. Okay, if you remove one hydrogen atom, it will be CH3 bond, that will be called as a methyl. It follows same for every alkyl groups. Okay, same for methane, propane, butane, pentane, everyone. Okay, next this 2 is called as a 2,2 dimethyl. Okay, what about this? At first position there is a chlorine atom. Okay, so it will be a 1 chloro, 1 chloro. Okay, fine. So what is the number of carbon atoms present here? 3 carbon atoms. So what is the name of that carbon atoms? Just follow the thing. That is monkeys eat peeled bananas. Monkeys eat peeled bananas. Okay, if you are not familiar with that thing, okay, like which will, if you are having confused what is the first thing, okay, then you have to go with this thing. Okay, so M will be the methane, E will be the ethane, P will be the propane, B will be the butane. Okay, so first 3 carbon atoms, it will be the third part, that is a propane. Okay, that is a pro. It is saturated, word root is done. What is the suffix? Primary suffix, that is saturation, that is the ANE, propane. Okay, next, is there any cyclo thing here? No. There is a functional group? No. Now we have to go for the substituent group. There are 2 substitutions, 1 and a 2. So which one you have to choose first? The one which comes in a first in the alphabetical order. Okay, so C comes first and then a D comes. So first we have to name it with the 1 chloro, 1 chloro, 2,2 dimethyl propane. Okay, this is how you have to label it. Okay, this is how you have to label it. Fine. So second one, I'm just giving the one more thing. I just like I just give you a word. Okay, I just give you the IUPAC name that should be converted into a structure. Okay, so it will be a like 2 chloro, 3 methyl pentane, 2 chloro, 3 methyl pentane. So pentane is the word, that means it is the longest chain. So write the pentane first, carbon, 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 carbon. Okay, pentane is done now. Okay, it is saturated completely, so no worry about the double bond. Next, at a second, just label this. Okay, 1, 2, 3, 4, 5 carbon atoms. At a second position, what is there? Chloro. So just add a chloro at this position. Next, third position, there is a methyl, CH3. So now satisfy the carbon valencies. Carbon should make a 4 bonds. So now this carbon has made already 1 bond. So 3 hydrogens. This is done with a 3 bonds. So add 1 hydrogen. This is done with a 3 bonds. Add 1 hydrogen. This is done with 2 bonds. Add 2 hydrogens. This is done with a 1 bond. So add 3 hydrogens. Done. Simple. Okay, it's not big issue. Okay, it's very simple thing. Next, I give you one more, that is example of the aromatics things. Okay, so if it is a like this compound, this is a, according to the classification, it is a trialoarene. Okay, it is a trialoarene. Okay, so if you want to label this, okay, if you want to label this with IUPAC name, so 1, 2, 3, 4, 5, 6, 6 carbon atoms. Go with the substituents first. So 1, 3, and 5. So okay, 1, 3, 5. How many bromines there? There are 3 bromines, so it is used as a tri. Okay, if it is 1, it is mono. You can see there, right? If it is a 1, mono, 2, di. Okay, so 1, 3, 5. Trialo. Okay, sorry, not trialo. Tri. What is this? Bromine, right? Tribromo. Okay, tribromo benzene. Okay, it is a 1 comma 3 comma 5 tribromobenzene. Okay, this is how you have to name it. Okay, so let me give you some work, like you guys just do it later. Okay, because like I'll just complete, I'm just late. Okay, so I should do this. Okay, so you can use some example problems yourself. Try to label this. So I mean, try to name the IUPAC name of this. Not now, just to be later. Just you can write. You can take a screenshot, or you can take down in a notebook if you are well in taking the notes. Okay, this compound. Next will be. If you have any doubts, you can just inform me later. Okay, this is the first question, second question, and third question. Okay, so now I'll go for the main part. Okay, now I'll go for the main part. I think you all done with this. Take a screenshot if you're not done. Fine. Now I'll talk with the nature. What is the nature of carbon halogen bond? Okay, what is the nature of a carbon halogen bond? How is the nature? Like, what is the bond? Like, this two has made a bond, right? So these two had bond are made. Okay, so fine, they have made the bond, no issue in that. But the main thing is that due to due to electronegativity difference, electronegativity difference, there arises a there arises a there arises the polarization. Okay, due to electronegativity difference, there arises the polarization. What is polarization? Polar nothing but the difference in the charges. Okay, the difference in the charges. Okay, the one which is more electronegative pull the electron pair towards itself. Okay, before it was like this, then after some time, after some time, not after some time, after the bonding, this bond pairs, okay, this bond pairs, the bond electrons are pulled towards the halogen atoms. That is maybe fluorine, chlorine, bromine, or iodine. Why? The reason is this group is more electronegative. This group is more electronegative. Due to this, what happens? These two get a partial charges. Okay, so the one which pulls electron more towards itself get a partial negative charge. The one which won't pull electron towards itself, like which will be far, electrons will be far from that will be getting a partial positive charge. Okay, this makes a polarity. This brings a polarity. Okay, polarity to the bond. This brings a polarity to the bond. Okay, due to this reason, there comes a many more reasons. Okay, due to this thing, okay, due to this thing, there comes a more and more properties. Okay, so let me talk one property. Okay, that is, so down the group, what happens? Down the group, down the group of this fluorine, chlorine, bromine, and iodine, size increases, and electronegativity also decreases. So as the size increases, the bond between carbon and halogens differs. The bond length increases. You can see. I'll just give you the example. I'll just show you with a picture, not picture, but like with writing this. This with a fluorine atom. Next with a alloy for a chlorine, it somewhat increases. Next with a bromine, it evolved somewhat bigger, and next with the carbon and iodine, it will be greater. Okay, the reason, what's the reason? That is the size factor. Okay, size factor. So the bond length is increasing here. Okay, the bond length is increasing. So what are different bond lengths you are getting here? For this, you are having a bond length of that is a 139 picometer. 139 picometer. What about this? Is having a 178. This is having a 193, and this is having a bond length of 214 picometer. What is picometer? Pico means it is a 10 by raised to minus 12, right? 12 meters. Okay. Picometer is nothing but a 10 raised to minus 12 meters. Okay. That's small. That much of small these halogens and the carbon bonds are. Not only halogen and carbon bonds, all organic molecules, all inorganic molecules make a covalent bonds will be very smaller in size. Okay. Next. So you all know that, right? So when the bond strength is, if the bond length is greater, you can break that bond very easily. It means that bond is not having a strength, right? You can take an example of a stick. Okay, so if a stick is bigger, You can break into equal halves very easily. If the stick is very smaller, can you break this easily? No, it's very difficult. ಅದೇ ತರ ಇಲ್ಲೂ ಅಷ್ಟೇ ಬಾಂಡ್ ಎಂಥಾಲ್ಪಿ ಅಂತ ಹೇಳೋಣ. ಓಕೆ, ಸೊ ಇಟ್ ಇಸ್ ಬಾಂಡ್ ಎಂಥಾಲ್ಪಿ ಆರ್ ಅ ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್. ಓಕೆ, the bond strength of this carbon and a fluorine ಇದಕ್ಕೆ ಜಾಸ್ತಿ ಇದೆ. The bond strength of a carbon and fluorine is greater. So okay, let me write its strength. Okay, it's having a 452 kilojoules per mole. Okay, ಇದಕ್ಕೆ ಏನಿದೆ? It's having a 351 kilojoules per mole. Okay, what about this? It's having a 293 and it is having a 234. What is the reason? ಇದೇ ರೀಸನ್, ಬಾಂಡ್ ಲೆಂತ್ ಜಾಸ್ತಿ ಇದೆ. ಸೊ ಬ್ರೇಕ್ ಮಾಡಕ್ಕೆ ಸ್ಟ್ರೆಂತ್ ನಮಗೆ ಜಾಸ್ತಿ ಬೇಡ, ವೆರಿ ಲೆಸ್ ಸ್ಟ್ರೆಂತ್ ಸಾಕು ನಮಗೆ. ಸೊ ಇಟ್ಸ್ ಹ್ಯಾವಿಂಗ್ ವೆರಿ ಲೆಸ್ಸರ್ ಸ್ಟ್ರೆಂತ್, ಇಟ್ಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಮೋರರ್ ಸ್ಟ್ರೆಂತ್ ಬಿಕಾಸ್ ಇಟ್ಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಗ್ರೇಟರ್ ಬಾಂಡ್ ಲೆಂತ್, ಸಾರಿ ಶಾರ್ಟರ್ ಬಾಂಡ್ ಲೆಂತ್. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಅ ಮೈನ್ ರೀಸನ್. ಓಕೆ, hence due to this the dipole moment also decreases down the group, okay, as the bond length increases the dipole moment also decreases. Okay, fine. Okay, I hope you understood this thing. So now we can go with the preparations. Okay, so how can you prepare? Okay, go for the preparations. How can you prepare haloalkanes and haloarenes? Okay, so first method we can follow by alcohols ಇಂದ ನಾವು haloalkanes ಮತ್ತೆ haloarenes ಪ್ರಿಪೇರ್ ಮಾಡಬಹುದು. ಓಕೆ, ಆಲ್ಕಲ್ ಹ್ಯಾಲೈಡ್ಸ್ ಅಥವಾ ಅರೈಲ್ ಹ್ಯಾಲೈಡ್ಸ್ ನ ಸೊ ಹೇಗೆ ಪ್ರಿಪೇರ್ ಮಾಡಬಹುದು? ಸೊ ಫಸ್ಟ್ ಏನಿಲ್ಲ, ಸಿಂಪಲ್ ಟೆಕ್ನಿಕ್. ಓಕೆ, ಸೊ ಏನು ಅಂದ್ರೆ ಈ OH ಗ್ರೂಪ್ ಇದೆಯಲ್ಲ, ಈ OH ಗ್ರೂಪ್, ಓಕೆ, ದಿಸ್ OH ಗ್ರೂಪ್ ಇದನ್ನ ನಾವು ಈಸಿಯಾಗಿ ರಿಪ್ಲೇಸ್ ಮಾಡಬಹುದು. ಓಕೆ, ದಿಸ್ OH ಗ್ರೂಪ್ ನ ನಾವು ಈಸಿಯಾಗಿ ರಿಪ್ಲೇಸ್ ಮಾಡಬಹುದು. ಏನಕ್ಕೆ ಅಂದ್ರೆ, ಸೊ ಎನಿ ಆಸಿಡ್ಸ್ ಇದ್ರೆ ಅನ್ಕೊಳ್ಳಿ, ಲೈಕ್ ಜಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್. ಓಕೆ, ಆಕ್ಸಿಜನ್ ಕಂಟೈನ್ಸ್ ಲೋನ್ ಪೇರ್ಸ್. ಈ ಲೋನ್ ಪೇರ್ಸ್ ಕೆಲಸ ಏನು ಅಂದ್ರೆ ಸುಮ್ಮನೆ ಇರಲ್ಲ ಅವು. ಓಕೆ, ಅವಕ್ಕೆ ಏನಾದ್ರು ಕಿತಾಪತಿ ಮಾಡ್ತಾ ಇರ್ಬೇಕು. ಇಫ್ ಯು ಕಂಟೈನ್ಸ್ ಎನಿ ಪ್ರೋಟಾನ್, ಓಕೆ, ಪ್ರೋಟಾನ್ ಅಥವಾ ಏನಾದ್ರು ಸಿಗ್ತಾ ಇದ್ರೆ ಇದನ್ನ ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಟ್ರೈ ಮಾಡ್ತಿರ್ತಾರೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೊಂಡಾಗ ಇಟ್ ಮೇಕ್ಸ್ OH2 ಅಂಡ್ ಗಾಟ್ ಅ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ಓಕೆ, ಸೊ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ ಫಾರ್ಮ್ ಆಯ್ತಾ ಇಲ್ಲಿ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇದೀಸೆಗೆ ಬಿಟ್ಟೋಗ್ಬೋದಾ? ಬಿಟ್ಟೋದ್ಮೇಲೆ ಏನಾಗುತ್ತೆ, ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಅ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಹಿಯರ್. ಅವಾಗ ಎನಿ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಲೈಕ್ ಅ Cl minus or a Br minus, okay, you ಬಂದು ಅಟ್ಯಾಕ್ ಮಾಡಬಹುದು ಇದ್ರ ಮೇಲೆ. then you are finally getting the R and a Cl, or it can be R and a Br. Okay, so this is one type of preparations. Okay, so ಈ ತರ ನಾವು ಪ್ರಿಪೇರ್ ಮಾಡಬಹುದು. Okay, ಬಟ್ ನಾವು ಈ ಮೆಥಡ್ ನ ಸದ್ಯಕ್ಕೆ ಯೂಸ್ ಮಾಡಲ್ಲ. we can use a different methods. Okay, so now by the alcohols we can use a different reagents to prepare this alkyl halides. Okay, so first OH groups treated with the HCl. Okay, HCl se treat ಮಾಡೋಣ. ಟ್ರೀಟ್ ಮಾಡ್ಬಿಟ್ಟು in the presence of, okay, HCl treat ಮಾಡಿ in the presence of zinc chloride. We are getting the alkyl chlorides and water. how ಹೇಗಪ್ಪ? ಸಿಂಪಲ್, ಏನಿಲ್ಲ, OH and H ಇದು ಜಾಗ ಖಾಲಿ ಮಾಡುತ್ತೆ. ಓಕೆ, ಇದು ಜಾಗ ಖಾಲಿ ಮಾಡಿ ಸೀದಾ H2O ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಮಿಕ್ಕಿದೇನಿದೆ, R ಮತ್ತೆ Cl ಇದೆಯಾ, ಇಷ್ಟೇ. ಇಲ್ಲೂ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ. ಸೊ R OH, ಸೊ R ಗ್ರೂಪ್ ಅಂದ್ರೆ ಅದು ಕಾರ್ಬನ್ ಅಟಮ್ಸ್ ಅಲ್ವಾ, ಲೈಕ್ CH3 ಗ್ರೂಪ್, CH3 OH. ಸೊ ಎರಡು ಪೊಲಾರಿಟಿ ಏನಿದೆ, ಆಕ್ಸಿನಿಕ್ ಪೊಲಾರಿಟಿ ಯಾವ್ದಕ್ಕೆ ಜಾಸ್ತಿ ಇದೆ? ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ನೆಗೆಟಿವ್ ಪೊಲಾರಿಟಿ. ಇದಕ್ಕೆ ಪಾಸಿಟಿವ್ ಪೊಲಾರಿಟಿನ ಹೈಡ್ರೋಜನ್ Cl ಅಲ್ಲಿ Cl ಇಸ್ ಅ ನೆಗೆಟಿವ್ ಪೊಲಾರಿಟಿನ ಈಗ ಅಟ್ರಾಕ್ಷನ್ ಯಾವ್ದಕ್ಕೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ? ಈ ನೆಗೆಟಿವ್ ಮತ್ತೆ ಈ ಪಾಸಿಟಿವ್ಗ. ಸೊ ಈಗ ಕೂಡ ನೀವು ಇದನ್ನ ಅನ್ಕೋಬಹುದು. ಓಕೆ, ದಿಸ್ ಆಲ್ ಅಬೌಟ್ ದ difference in their polarity. Okay, this is all about the difference in their polarity. Okay, fine. So this is the one method. Okay. Next you can go with the taking the ROH with the SOCl2. What is SOCl2? SOCl2 andre it is a thionyl chloride. So ಇದನ್ನ ಟ್ರೀಟ್ ಮಾಡಿದ್ರೆ ಇಟ್ಸ್ ಅ ಬೆಸ್ಟ್ ಪ್ರಿಪೇರ್ಸ್. ಓಕೆ, ಸೊ thionyl chloride ಜೊತೆ ನಾವು ಆಲ್ಕೋಹಾಲ್ ನ ಟ್ರೀಟ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಬರ ಅಂತ ಆಲ್ಕೈಲ್ ಹ್ಯಾಲೈಡ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ದ ಬೆಸ್ಟ್ ಆಲ್ಕೈಲ್ ಹ್ಯಾಲೈಡ್. ಏನಕ್ಕೆ ಅಂದ್ರೆ ಇದರಲ್ಲಿ ಇದನ್ನ ಪ್ರಿಪೇರ್ ಮಾಡಕ್ಕೆ ನೀವು ಜಾಸ್ತಿ ಕಷ್ಟಪಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಏನಕ್ಕೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ SO2 ಗ್ಯಾಸ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಓಕೆ, ಇಲ್ಲಿರೋ ಅಂತ ಆಕ್ಸಿಜನ್ ಮತ್ತೆ ಇಲ್ಲಿ SO. ಓಕೆ, ಇದು SO2 ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಇನ್ ಮಿಕ್ಕಿರೋದು ಯಾವುದು? 1 Cl ಈ ಆರ್ ಮತ್ತೆ 1Cl ಏನ್ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ RCl ಕನ್ವರ್ಟ್ ಆಗುತ್ತಾ ಆಲ್ಕಲೈ ಹ್ಯಾಲೈಡ್ ನಿಮಗೆ ಬೇಕಾಗಿರೋದೇ ಅಲ್ವಾ ಆಲ್ಕಲೈ ಹ್ಯಾಲೈಡ್ಸ್ then the remaining what remaining this hydrogen atom and one more Cl atom from this that will get converted into a HCl ಇವೆರಡೂ ಕೂಡ in the form of a gas ಅವಾಗ ಏನಾಗುತ್ತೆ if it is a gas they just get liberated out and you are getting this alkyl halide liquid okay ಈ alkyl halide ನಿಮಗೆ liquid form ಅಲ್ಲಿ ಪ್ಯೂರ್ ಆಗಿ ಸಿಗುತ್ತೆ ಇವೆರಡು ಕೂಡ ಗ್ಯಾಸ್ ಆಗಿ ಆಚೆ ಹೋಗುತ್ತೆ ಸೊ ನೀವು ಇಲ್ಲಿ ಮತ್ತೆ ನೆಕ್ಸ್ಟ್ ಕಷ್ಟಪಡೋ ಅವಶ್ಯಕತೆ ಏನು okay you are directly getting this reaction okay it is ROH or let me take any example of this if I take an example of CH3 Cl with sorry CH3Cl not CH3Cl OH with OH plus SOCl2 and you are treating the CH3Cl CH3Cl sulfur dioxide and HCl okay this is the reaction how you can prepare okay we are preparing the methyl chloride na prepare ಮಾಡ್ತಾ ಇದೆ okay you are liberating out the sulfur dioxide and HCl is giving out as a fumes okay ಇದು is liberating out as a fumes okay fumes are ಆಚೆ ಬರುತ್ತೆ okay you know like HCl is more concentrated acid right in your laboratory you can or you have already seen that like when you remove the cap it just it shows a fuming way right okay so next preparation you can go with the help of a red phosphorus okay so in your P block okay in your P block you have studied about the phosphorus right so allotropies of phosphorus in that you have studied about P4 red phosphorus we are using a P4 red phosphorus and treating this P4 with the 5 moles of Br2 or you can treat with a Cl2 anything this gives you a 4 moles of PCl3 okay phosphorus trichloride okay when you treat this phosphorus trichloride ಈ phosphorus trichloride ನ ನೀವು ಮತ್ತೆ ಇದನ್ನ okay ಮತ್ತೆ ಇದನ್ನ ಆಲ್ಕೋಹಾಲ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದ್ರೆ ಏನ್ ಕೊಡುತ್ತೆ when you treat this phosphorus trichloride with an alcohol ಏನ್ ಕೊಡುತ್ತೆ ಇಲ್ಲಿ you are getting the alkyl halide and you are getting the ನೋಡಿ ಇನ್ನೇನು ಉಳಿದಿದೆ ಇಲ್ಲಿ you will take this 3 moles ಯೂಸ್ ಆಗುತ್ತೆ ಅವಾಗ ಏನಾಗುತ್ತೆ the remaining what is remaining here you are getting a 3 moles of RCl because you are taking a 3 moles of alcohol means you are getting a 3 moles of RCl ಇಲ್ಲೂ 3 ಕ್ಲೋರಿನ್ ಇದೆ ಇಲ್ಲೂ 3 R ಗ್ರೂಪ್ ಇದೆ ಮತ್ತೆ ಇನ್ನೂ 3 OH ಗ್ರೂಪ್ O ಗ್ರೂಪ್ ಉಳಿತು ಇನ್ನು 4 ಇದ್ಬೇಡಿ you are taking only this amount okay ಇನ್ನು 3 ಅಮೌಂಟ್ ಹೈಡ್ರೋಜನ್ ಉಳಿತಾ H3 and we left with the phosphorus okay this is nothing but H3PO3 what is this okay this is the orthophosphorus acid right it is orthophosphorus acid you are getting the alkyl chloride ಎರಡು ಸಿಕ್ತು ನಿಮಗೆ ಸಿಂಪಲ್ ಅಲ್ವಾ why I did this thing is that ನಾನು ಯಾಕೆ ಇದನ್ನ ಮಾಡದೆ ಮುಂಚೆ ಅಂದ್ರೆ ಇದನ್ನ ನೀವು in situ ಅಲ್ಲಿ ಪ್ರಿಪೇರ್ ಮಾಡ್ಬೇಕು in situ ಅಂದ್ರೆ ತಕ್ಷಣನೇ ಪ್ರಿಪೇರ್ ಮಾಡಿದ ತಕ್ಷಣ you have to react with the alcohol ಇಲ್ಲ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ this will get liberated out ಅಥವಾ ಇದು ನಿಮಗೆ ರಿಯಾಕ್ಟ್ ಆಗಲ್ಲ ನೀಟಾಗಿ ಓಕೆ ಸೊ ಇದು ನಿಮಗೆ ಈಸಿಯಾಗಿ ರಿಯಾಕ್ಟ್ ಆಗಲ್ಲ ಸೊ in situ ಪ್ರಿಪರೇಷನ್ ಮಾಡಿದ್ರೆ ಮಾತ್ರ you are getting the good alcohols you can react with the alcohols okay so next thing you can prepare with the help of a ಇವೆಲ್ಲ alcohol preparations okay you are doing with alcohols preparations itself okay so next you can do with the help of a ROH with the NaBr sodium bromide you are reacting this with the H2SO4 sulfuric acid okay this is giving you a alkyl bromide plus sodium bisulfate plus giving you a water okay so it's giving a alkyl bromide and a sodium bisulfate and a water okay you can see the what's the reaction is going on here okay simple ಏನಿಲ್ಲ ಏನಂದ್ರೆ ಇಲ್ಲಿ OH ಮತ್ತೆ sulfuric acid ಇದೆಯಲ್ಲ ಇಲ್ಲಿಂದ ನಿಮಗೆ ಸಲ್ಫರ್ like if you draw the structure of this okay let me show this how it is okay H2SO4 okay you take this like you are having a hydrogen here in this case okay so this is removed out as a water okay and here what is left out you are left out with the HSO okay HSO4 minus and this react with the Na sodium bisulfate banta sodium bisulfate now ಇನ್ನೇನು ಉಳಿದಿದೆ bromine ಉಳಿದಿದೆ R group ಉಳಿದಿದೆ and that is you are getting RBr okay simple fine next Next, we are going with the which like tertiary, secondary, and primary alcohols. ಓಕೆ, ನಾನು ಅವಾಗಲೇ ಹೇಳಿದ್ದೆ ಅಲ್ವಾ. ಸೊ ಟರ್ಷರಿ, ಪ್ರೈಮರಿ ಅಂಡ್ ಸೆಕೆಂಡರಿ ಆಲ್ಕೈಲ್ ಆಲೈಡ್ಸ್ ಬಗ್ಗೆ ಹೇಳ್ತಿದ್ದೆ, ಆಲ್ಕೈಲ್ ಆಲೈಡ್ಸ್ ಬಗ್ಗೆ. ಈಗ ಆಲ್ಕೋಹಾಲ್ಸ್ ಬಗ್ಗೆ ಹೇಳ್ತಾನೆ. ಏನಕ್ಕೆ ಅಂದ್ರೆ ಇದರಲ್ಲಿ ಯಾವುದು ಟರ್ಷರಿ ಆಲ್ಕೋಹಾಲ್ ಇದೆಯಲ್ಲ, ಟರ್ಷರಿ ಆಲ್ಕೋಹಾಲ್ ಅದು ತುಂಬಾ ರಿಯಾಕ್ಟಿವ್. ಓಕೆ, ನೀವು ಅದನ್ನ ಸುಮ್ಮನೆ ಏನ್ ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ ಯು ಟೇಕ್ ಅ ಟರ್ಷರಿ ಆಲ್ಕೋಹಾಲ್ ಅಂಡ್ ಯು ಆರ್ ಟ್ರೀಟಿಂಗ್ ದಿಸ್ ವಿತ್ HCl. ಓಕೆ, HCl ಇದನ್ನ ಸುಮ್ಮನೆ ಈ ಲಿಕ್ವಿಡ್ ಮಿಕ್ಸ್ ಮಾಡ್ಬಿಟ್ಟು ಶೇಕ್ ಮಾಡಿದ್ರೆ ಸಾಕು. ಇಫ್ ಯು ಶೇಕ್ ದಿಸ್ ಯು ಆರ್ ಗೆಟಿಂಗ್ ದ ಟರ್ಷರಿ alide and water. ಸಿಂಪಲ್, ಶೇಕ್ ಮಾಡಿದ್ರೆ ಸಾಕು, ಏನು ಜಾಸ್ತಿ ಅವಶ್ಯಕತೆನೇ ಇಲ್ಲ. ಓಕೆ, ಆದ್ರೆ ಇಫ್ ಯು ಟೇಕ್ ಸೆಕೆಂಡರಿ ಅಂಡ್ ಸೆಕೆಂಡರಿ ಅಥವಾ ಪ್ರೈಮರಿ ತಗೊಂಡ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಯೂಸ್ ದ ಕೆಟಲಿಸ್ಟ್ ಹಿಯರ್. ಓಕೆ, ಅವೆಲ್ಲ ಹೇಳಿದ್ನಲ್ಲ, ಜಿಂಕ್ ಕ್ಲೋರೈಡ್ ನ ಕೆಟಲಿಸ್ಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡಬೇಕು. ಇಟ್ ಇಸ್ ನೆಸೆಸರಿ. ಓಕೆ, ಬಿಕಾಸ್ ದೀಸ್ ಆರ್ ಲೆಸ್ ರಿಯಾಕ್ಟಿವ್. ಓಕೆ, ದೀಸ್ ಆರ್ ಮೋರ್ ರಿಯಾಕ್ಟಿವ್. Okay, these are more reactive, these two are less reactive. Okay, and you're getting the secondary or primary alkalides and a water. Okay, this is how you can prepare this. Okay, so this is the preparation with an alcohol, preparation with the help of an alcohol. Okay, next preparation with the hydrocarbons. Okay, hydrocarbons. So in this you are first studying with the free radical. Okay, you are getting with the free radical halogenation in your 11th chapter. Okay, in your 11th chapter you are doing with hydrocarbons. In that you are studied in alkanes, the halogenation reaction. Okay, that is what this idu matte edru ondene. Okay, so free radical halogenation. Okay, this is a free radical halogenation. So what you are doing in this case, you are taking a methane and you are treating with a 1 mole of Cl2 in the presence of, ನೆನ್ಪಿಟ್ಕೊಂಡಿರಿ, when you are taking a free radical is only possible when you are just eating this or when you are passing a sunlight through it. Okay, sunlight na pass ಮಾಡಿದಾಗ ಅಥವಾ eat ಮಾಡಿದಾಗ you are getting the free radical. What is free radical? Free radical means there is a homolytical cleavage. ಏನಪ್ಪ homolytical cleavage ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ. ಸೊ ಇವೆರಡು ಬಾಂಡ್ ಹೇಗೆ ಫಾರ್ಮ್ ಮಾಡಿರುತ್ತೆ? ಬೈ ಶೇರಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್, ರೈಟ್? ಒನ್ ಬೈ ಶೇರಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್. ಇದು ಈಕ್ವಲ್ ಆಗಿ ಈ ತರ ಕ್ಲೀವ್ ಆದ್ರೆ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ ಹೋಮೋಲಿಟಿಕಲ್ ಕ್ಲೀವೇಜ್. ಅದೇ ಇದು ಅನ್ಈಕ್ವಲ್, ಲೈಕ್ ಯಾವ್ದಾದ್ರು ಒಂದ್ ಕಡೆ ಜಾಸ್ತಿ ಆದ್ರೆ ಈ ಕಡೆ, ಇಫ್ ಯು ಕ್ಲೀವ್ ಇನ್ ದಿಸ್ ವೇ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ heterolitical cleavage. It's called heterolitical cleavage. From this you are getting the Cl radical, chlorine free radical and chlorine free radical. From this you are getting the one cation and one chlorine anion. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಸೊ ಹೌ ಟು ಡೂ ದಿಸ್? ಅದು ನಿಮಗೆ ಈಕ್ವಲ್ ಆಗಿ ಲೈಕ್ ಬಾಂಡ್ ಮಾಡುವಾಗ ಏನಾಗಿರುತ್ತೆ, ಕೋಲೆಂಟ್ ಬಾಂಡ್ ಮಾಡುವಾಗ ಈಕ್ವಲ್ ಶೇರಿಂಗ್ ಆಗಿರುತ್ತಾ? ಆ ಶೇರಿಂಗ್ ಆಗಿರೋದು ಈಕ್ವಲ್ ಆಗಿ ಬ್ರೇಕ್ ಆದ್ರೆ ದಟ್ ವಿಲ್ ಗೆಟ್ ಹೋಮೋಲಿಟಿಕಲ್ ಕ್ಲೀವೇಜ್ ಅಂಡ್ ದಟ್ ಗಿವ್ಸ್ ಅ ಫ್ರೀ ರಾಡಿಕಲ್. ಆಮೇಲೆ ಅದು ಹೆಟರೋಲಿಟಿಕಲ್ ಕ್ಲೀವೇಜ್ ಆದ್ರೆ ಒನ್ ಗಿವ್ಸ್ anion, one gives cation. Okay, it is called a heterolitical cleavage. Okay, ಈಗ ನಾವು ಇನ್ ದಿಸ್ ಕೇಸ್ ಈ ರಿಯಾಕ್ಷನ್ ಏನಾಗ್ತಿದೆ, ಈ ರಿಯಾಕ್ಷನ್ ನಾವ್ ಏನ್ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ಫ್ರೀ ರಾಡಿಕಲ್ ನ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ನಮಗೆ ಇಲ್ಲಿ ಏನಾಗಿರ್ಬೇಕು, ಇಲ್ಲಿ ನಾವು ಏನಾದ್ರು ಈಟಿಂಗ್ ಅಥವಾ ಸನ್ಲೈಟ್ ನ ಪಾಸ್ ಮಾಡಬೇಕು. ಓಕೆ, ಅದನ್ನ ಇಲ್ಲಿ ನೋಡೋಣ. ಇನ್ನೊಂದು ಇಲ್ಲಿ ನೋಡಿ, CH4 treating with a Cl2 in the presence of a heat, that is H nu. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ you are getting the CH3 Cl ಬಂದಿರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಅಗೈನ್ ಪ್ಲಸ್ HCl ಬರುತ್ತೆ. ಯಾಕೆಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ ಕಾರ್ಬನ್ ಹೈಡ್ರೋಜನ್ ಇದೆ, ಹೈಡ್ರೋಜನ್ ಇಲ್ಲಿ Cl ಇದೆಯಾ. ಸೊ ಇವೆರಡು ಬಾಂಡ್ ಮಾಡುತ್ತಾ, ಆಮೇಲೆ ಇವೆರಡು ಬಾಂಡ್ ಮಾಡುತ್ತಾ, ಹೀಗೆ. ಓಕೆ, ಕಾರ್ಬನ್ ಮೇಕ್ಸ್ ಅ ಬಾಂಡ್ ವಿತ್ ಅ Cl and one more hydrogen makes a bond with a Cl. Okay, this gives you what? HCl and you are getting the methyl chloride. ಮತ್ತೆ again when you treat with the 3 moles of Cl2, 1 mole of Cl2 ಬಂದಿದ್ರೆ ಒಂದು ಹೈಡ್ರೋಜನ್ ರಿಪ್ಲೇಸ್ ಆಗಿ you are getting the the chlorine. Okay, so when you treat this compound again with the 3Cl2, so what you are getting, the completely hydrogens are replaced here. Okay, completely hydrogens are replaced here. Okay, that is CCl4, you got completely CCl4 and 3 moles of HCl has been liberated out. Okay, This is how you can prepare with the help of this thing. Okay, so this is having a lot big mechanism, but that is not necessarily right now. Okay, ಅದೇನ್ ಬೇಕಾಗಿಲ್ಲ. ಸೊ ಹೇಳ್ತೀನಿ, just simple ಆಗಿ ಹೇಳೋದಾದ್ರೆ, so ಅದರಲ್ಲಿ 3 steps ಇರುತ್ತೆ. Okay, so first step is the like initiation step. Initiation. It's the initiation. Okay, so Cl2 H nu ಜೊತೆ Cl radical and Cl radical ಆಗಿ ಬ್ರೇಕ್ ಆಗುತ್ತೆ. ಅದಾದ್ಮೇಲೆ ಪ್ರೊಪಗೇಷನ್ ಕಂಟಿನ್ಯೂ ಮಾಡೋದು. ಪ್ರೊಪಗೇಷನ್ ಅಂದ್ರೆ ಇಲ್ಲಿ CH4 Cl ಜೊತೆ ಸೇರಿಸ್ಕೊಂಡು ಏನ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ CH4 Cl radical ಜೊತೆ you are getting the CH3Cl and H radical, or like you can treat with directly with this Cl2. Okay, not with the radical. You're treating this with Cl2, that is giving the Cl radical. So still in a propagation there are many types of reaction. Okay, next Cl3Cl ಇದೆ, ಮತ್ತೆ ಏನಾಗುತ್ತೆ ಈ Cl radical ಟ್ರೀಟ್ ಆಗುತ್ತೆ. ಟ್ರೀಟ್ ಮಾಡ್ಬಿಟ್ಟು ಏನಾಗುತ್ತೆ, you are getting the CH2Cl2. Okay, CH2Cl2, or you are getting the CH2Cl CH3Cl plus, wait a minute, so you are getting the, okay, you are getting your the CH2Cl plus HCl. Okay, again you are getting the this CH2Cl, ಇದು radical ಅಲ್ವಾ, CH2Cl, ಇದು ಇನ್ನೊಂದು ಕ್ಲೋರಿನ್ ಜೊತೆ ಸೇರ್ಬಿಟ್ಟು Cl ಜೊತೆ ಸೇರ್ಬಿಟ್ಟು you are getting the CH2Cl2 plus Cl radical. Okay, so like I think this is not required. Okay, ಇವೆಲ್ಲ ಬೇಕಾಗಿಲ್ಲ, ಆದ್ರೆ ಸುಮ್ಮನೆ ಹೇಳ್ತಾನೆ ಅಷ್ಟೇ, just to know how ಯಾವ ತರ ಆಗುತ್ತೆ ಅಂತ. Okay, so ಸಿಂಪಲ್ ಏನಿಲ್ಲ, ಈಗ ಇವೆರಡು ರಿಯಾಕ್ಟ್ ಹೇಗಾಗುತ್ತೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಇದೇ ಮೆಕ್ಯಾನಿಸಮ್ ಎಲ್ಲ ಕಡೆನೂ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿರುತ್ತೆ. Okay, so this is a Cl and this is a Cl radical. ಓಕೆನಾ, ಸೊ ಇಲ್ಲಿ ಎರಡು ಲೋನ್ ಪೇರ್ಸ್ ಇರುತ್ತೆ, ಇಲ್ಲಿ ಬಾಂಡ್ ಪೇರ್ಸ್ ಇರುತ್ತೆ ಎರಡು. ಸೊ ದಿಸ್ ವಿಲ್ ಟೇಕ್ ಒನ್ and this will take one. Okay, so now what you are getting, you are getting the CH3 radical plus Cl radical and ECl radical. Okay, ಅವಾಗ ಏನಾಗುತ್ತೆ, this radical and this radical, two electrons make a bond like this Cl. Okay, this becomes a radical now. Okay, like this, the same mechanism, ಇದೆಲ್ಲ ಅದೇ mechanism. Okay, first is the initiation, propagation, at last you are getting the termination. Okay, ಅಲ್ಲಿ ಸ್ಟಾಪ್ ಮಾಡ್ಬೇಕು, ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಎಲ್ಲ ಖಾಲಿ ಆಗಿರುತ್ತೆ, ಅವಾಗ ಟರ್ಮಿನೇಷನ್ ನ ಸ್ಟಾಪ್ ಮಾಡ್ಬೇಕು. ಟರ್ಮಿನೇಷನ್ meaning ಬಿಟ್ಟು stopping of this. Okay, so this is all about the free radical halogenation. Okay, free radical halogenation. By this you are preparing the alkyl chlorides. Okay, so alkyl halides. Okay, so there's a one more reaction. Okay, so simple reaction idu andre, like I am just like long reaction, doddo reaction tar, that is like you are getting a mixture of products. Okay, like mixture of product, like not only single product, you're getting many, like see, you got CH3Cl and also you will get a CH2Cl2 and also you will get a CHCl3. What is CHCl3? CH is named with a chloroform, right? It's a chloroform. Okay, if you get a CCl4, okay, you're getting this also. Okay, because this is a chain reaction. Okay, this is a chain reaction. Chain stop agutta, chain illa continue agta hogutte. Okay, this is a chain reaction. Okay, CCl4, what is CCl4? Carbon tetrachloride. It's a carbon tetrachloride. Okay, fine. So these are all products you are getting in this reaction. Okay, these are all the products you are getting in this reaction. Okay, these are all like halides itself. Okay, these are all alkyl halides itself. Fine. So next I am going with the electrophilic substitution reaction. Okay, so electrophilic substitutions by, what is electrophilic substitution reaction? What is electrophilic substitution? That means you are adding up an electrophile here. Okay, you are adding electrophile to a richer group. Okay, electron richer group ಗೆ ಏನ್ ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ electrophile add ಮಾಡ್ತೀರಾ. So electrophile ಅದು halides ಆಗಿರ, like if it's a Cl plus, then you are getting alkyl halide or aryl halide. Okay, so by the electrophilic substitution reaction, okay, by electrophilic substitution reaction, you are preparing the aryl halides. I am taking example of a toluene. Okay, this is a toluene. Okay, so it is a toluene. I am treating toluene with the halogen. Okay, generally X will be chlorine or it will be a bromine. I'll tell why only these two will be there. I'll tell the reason why. This is treated in presence of a catalyst. What does a catalyst do? What does a catalyst do? Catalyst enhances the rate of the reaction. Reaction ಸ್ಲೋ ಹೋಗ್ತಿರುತ್ತೆ ಅನ್ಕೊಳ್ಳಿ. ಈಗ ಆಮೆ ಹೋಗ್ತಾ ಇರುತ್ತೆ ಇಲ್ಲಿ, ಓಕೆ, ಅವ್ರ ಪಕ್ಕದಲ್ಲಿ ಮೊಲ ಬಂದಿರುತ್ತೆ. ಓಕೆ, ಸೊ ಯಾವ್ದು ಫಸ್ಟ್ ಹೋಗುತ್ತೆ? ಇದೆ ಅಲ್ವಾ? ಇದಕ್ಕೆ ಏನಾಗ್ತಿದೆ? ಇಯರ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಈಸ್ ಯೂಸಿಂಗ್. ಓಕೆ, ಸೊ ಓಕೆ, ಆಮೆ ಮೊಲ ಇದ್ರೆ ಏನ್ ಮಾಡ್ತೀರಾ? ಆಮೆ ಮೊಲ ಇದ್ರೆ ಇದು ಹೆಂಗಿದ್ರು ಫಾಸ್ಟ್ ಆಗಿ ಹೋಗುತ್ತೆ ಮೊಲ. ಅವಾಗ ಏನ್ ಮಾಡ್ತೀರಾ? ಟರ್ಟಲ್ಗೆ ಅಥವಾ ಆಮೆಗೆ ಏನ್ ಮಾಡ್ತೀರಾ? ಕ್ಯಾಟಲಿಸ್ಟ್ ಆಡ್ ಮಾಡೋದು. ಆಮೇಲೆ ಕೆಟಲಿಸ್ಟ್ ಆಡ್ ಮಾಡಿದ್ರೆ ಇದು ರಾಬಿಟ್ ಗಿಂತ ಫಾಸ್ಟ್ ಆಗಿ ಓಡುತ್ತೆ. ಓಕೆ, ದಟ್ ಈಸ್ ವಾಟ್ ದ ಕೆಟಲಿಸ್ಟ್ ಡು. ಜಾಸ್ತಿ ಸ್ಪೀಡ್ ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡುತ್ತೆ. ಇಟ್ ಎನ್ಹಾನ್ಸಸ್ ದ ರೇಟ್ ಆಫ್ ದ ರಿಯಾಕ್ಷನ್. ಟರ್ಟಲ್ ದ ಸ್ಪೀಡ್ ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡೋದು. ಓಕೆ, ಸೊ ದ ಸೇಮ್ ಥಿಂಗ್, ವಿ ಆರ್ ಜಸ್ಟ್ ಡೂಯಿಂಗ್ ದ breaking out here between this xx there is a heterolytic cleavage. Okay, there is a heterolytic cleavage. X plus is added to this group. Okay, so you're getting the two types of product. One is the para and one is the ortho. Okay, you're getting the ortho and a para. So CX3 and you're getting, this is the ortho, right? This position is called as ortho position. Okay, this is the ortho position and this is the meta position and this is the para position. So I'm getting the two types of product. What are those? One is the CH3X and one more is the okay. So what is this name? Is you can call it as a orthohalotolin. Orthohalotolin. You can name it as a parahalotolin. Okay, these are two types of products you're getting. So this product can be easily what? Separated. How? By the fractional distillation. Okay, in your 11th chapter you have studied the fractional distillation, right? Okay, so ಏನ್ ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ ಇವೆರಡು ಕಾಂಪೌಂಡ್ ನು ಕೂಡ ಸೊ ಈಟ್ ಮಾಡ್ತೀರಾ. ಸೊ ವಿಚ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ವೊಲಟೈಲಿಟಿ. ಓಕೆ, ವಿಚ್ ಇಸ್ ಮೋರ್ ವೊಲಟೈಲ್, ಅದು ಆಚೆಗೆ ಬಂದ್ಬಿಡುತ್ತೆ ಬೇಗ, ಗ್ಯಾಸ್ ಆಗ್ಬಿಟ್ಟು. ಯಾವ್ದು ವೊಲಟೈಲ್ ಇಲ್ವೋ ಅದು ಅಲ್ಲೇ ಇರುತ್ತೆ. ಓಕೆ, so this is how you can preparing the alkyl halides. So aryl halides. Okay, orthohalotolin, parahalotolin. So I told you what? If you react fluorine is what? It is more reactive. Fluorine more reactive ಇರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ it gives a desired product. Okay, ನಮಗೆ ಏನ್ ಬೇಕೋ ಅದು ಕೊಡಲ್ಲ, ನಮಗೆ ಬೇಕಾಗಿರೋದೇ ಕೊಡುತ್ತೆ ಇಲ್ಲಿ, desired product. So not a desired, like it's a discrete product. Okay, better product, fine, or unwanted product. Next, when you treat chlorine, it gives a good reaction. If you treat with bromine, it is also giving good reaction. But when you treat with iodine, okay, so iodine is a least reactive. Okay, it's very least reactive. That means it gives a equilibrium reaction. It gives a equilibrium reaction. ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ when you treat this with I2, it get converted into a hydrogen iodide. Okay, ಈ ತರ ಕನ್ವರ್ಟ್ ಆಗ್ಬಿಡುತ್ತೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ? You won't get a reaction. Okay, so your reaction will not be favored. Okay, favored. So what you are using? So you are using any acids like a HNO3. Okay, HNO3, or you can use a HiO4. Okay, like this acids you can use in the presence of a in the presence of an iodine, and you are getting the para-iodotolin, or you are getting the ortho-iodotolin. Okay, so next important reaction, that is a Sandmeyer's reaction. That is a Sandmeyer's reaction. What is Sandmeyer reaction? Simple, conversion of amine. Okay, aryl amine. Okay, conversion of this amine or aniline, we call it as aniline. Okay, conversion of aniline to a directly to an aryl halides, okay, this process is done by the Sandmeyer reaction. How? So we are going with the different steps. Okay, so first step is a diazotization step. Okay, it is called as a diazotization step. Diazotization illa en ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ diaza. What is diaza? It means aza means it's called nitrogen. Okay, diaza means ಎರಡು nitrogen ಅಂತ. So N. Okay, this you are bringing together. Okay, so how do you do this? When you treat with the sodium nitrite, okay, treating with the NaNO2 with the HX, any halogen group. Okay, at 0 degree to 5 degree Celsius, or again Kelvin 273 to 278 Kelvin. Okay, this is converted into a benzene diazonium salt, like is N2 plus X minus. Okay, like this it has been converted. When you treat NaNO2 and a hydrogen halide in a presence with 0 to 5 degrees Celsius, it has been converted into a benzene diazonium halide. Benzene diazonium halide. Okay, benzene diazonium halide. Okay, so what is the use of this benzene diazonium halide? ಏನು ಯೂಸ್ ಇದು ಮಾಡ್ಬಿಟ್ಟು ಏನು ಮಾಡೋಣ ಈಗ ನಮಗೆ ಬೇಕಾಗಿರೋದೇನು? We need this. So how to do it? When you get a benzene diazonium halide, this N2 is a good leaving group. N2 is a good leaving group. Okay, so leaving group ಅಂದ್ರೇನು? ಈಸಿಯಾಗಿ ಬಿಟ್ಟೋಗೋ group. Okay, so when you treat this with any halogens, that you can, I am treating this with the cuprous chloride. Okay, Cu2X2. Okay, it is called as a cuprous chloride. So what you are getting? Directly you are getting the chlorobenzene. Okay, you are getting the X. Okay, cuprous chloride or like a cuprous halide. You can take a halides. Okay, that is giving a directly halobenzenes with N2 as a byproduct. Okay, N2 as a gas leaving group. Okay, this is the reaction. You can see first I took a aniline treated with a sodium nitrate. Okay, NaNO2. Sorry, sodium nitrite. Okay, it's a nitrite, right? Sodium nitrite. Okay, if it is a NO3, it will be a nitrate. Now it is a NO2, it is a nitrite. Okay, treating this with a hydrogen halide at a 0 to 5 degrees Celsius, and you're getting the benzene diazonium halide. Okay, you're getting the benzene diazonium halide, and this benzene diazonium halide treated with the cuprous halides. Any cuprous halides, you are getting the benzene halides. Okay, and the N2 has a good leaving group, and it liberates from this place. Okay, this is how you can do. So if I give one more reaction for this, like treating this benzene diazonium halide with potassium iodide. With potassium iodide, I am treating potassium iodide here. Okay, so for the chlorines and the bromines, I go in this process. Okay, but potassium iodide is very less reactive, right? So what I do, I am just taking this, I am just shaking this. I am taking the benzene diazonium halide. Benzene diazonium solid one container like taking a test tube. Okay, so take a test tube and add a benzene diazonium halide to this, and upon that you can add a potassium iodide like this. So what happens? Just close this with your thumb and shake this well. So finally you are getting the iodobenzene. Okay, you are getting the iodobenzene, and N2 is the gas liberated when you remove the thumb out. Okay, so this is how you can prepare the benzene halides with the help of a Sandmeyer's reaction. Okay, so next reaction is, so if I talk with the next reaction, that will be the from alkenes. Don't worry, so there are very less things. Okay, so next we'll go with only 2 reactions are there. Okay, so one with the alkenes and one with the halogen exchange method. Okay, 2 types of preparations. Okay, first I'll go with the from alkenes. Okay, so now as alkenes, in this alkenes, before going to the alkenes, I like to talk about the Markovnikov's rules. Markovnikov's rule. I think you guys are familiar with the Markovnikov's rule. ಏನು Markovnikov's rule ಅಂದ್ರೆ ಸಿಂಪಲ್ ಕೋಡ್ ಪ್ರಕಾರ ಇದಕ್ಕೆ ಒಂದು ಕೋಡ್ ಇಟ್ಟಿ ನಾನು, ದಟ್ ಈಸ್ NaCl ಅಂತ. NaCl ಏನಪ್ಪ NaCl ಅಂದ್ರೆ, N ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಅಂತ, A ಅಂದ್ರೆ ಅಟ್ಯಾಕಿಂಗ್ ಅಂತ, C ಅಂದ್ರೆ ಕಾರ್ಬನ್ ಕಂಟೈನಿಂಗ್, L ಅಂದ್ರೆ ಲೀಸ್ಟ್ ಕಡಿಮೆ, ಲಿಸ್ಟ್ ಅಲ್ಲ, LEAST ಲೀಸ್ಟ್. ಓಕೆ, ಸೊ ನೆಗೆಟಿವ್ ಪಾರ್ಟ್ attacks carbon containing least number of hydrogen atom. Okay, negative part attack carbon containing least number of hydrogen atom. ಏನಪ್ಪ ಹಿಂಗಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ. So you take any alkene here. So alkene ತಗೊಂಡಿರಾ, ಆಲ್ಕೀನ್ ನೀವು ಹೈಡ್ರೋಜನ್ ಆಲೈಡ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಅಡಿಷನ್ ಪ್ರಾಡಕ್ಟ್, ದಿಸ್ ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ವಾ ಇದು ಡಬಲ್ ಬಾಂಡ್. ಇದು ಡಬಲ್ ಬಾಂಡಿಗೆ ಅಡಿಷನ್ ಮಾಡ್ತೀರಾ. ಏನ್ ಆಡ್ ಮಾಡ್ತೀರಾ? ಯು ಆರ್ ಆಡಿಂಗ್ ದ ಕಾರ್ಬನ್ ಕಾರ್ಬನ್ ಅಂಡ್ ಹೈಡ್ರೋಜನ್ ಅಂಡ್ ಅಯೋಡೈಡ್. ಓಕೆ, ಸೊ ಈ ತರ ಆಡ್ ಮಾಡ್ತೀರಾ. ಇಫ್ ದಿಸ್ ಇಸ್ ಸಿಮಿಟ್ರಿಕ್ ಮಾಲಿಕ್ಯೂಲ್, ಓಕೆ, ಇದು ಸಿಮಿಟ್ರಿಕ್ ಅಂದ್ರೆ ಈಕ್ವಲ್ ಆಗಿ ಹಾಫ್ ಕಟ್ ಮಾಡಿದ್ರೆ ಯು ಗೆಟಿಂಗ್ ಟೂ ಈಕ್ವಲ್ ಹಾಫ್ಸ್, ಲೆಫ್ಟ್ ಸೈಡ್ ಅಂಡ್ ರೈಟ್ ಸೈಡ್. ಓಕೆ, ಸೊ ಈ ತರ ಸಿಮಿಟ್ರಿಕ್ ಮಾಲಿಕ್ಯೂಲ್ ಇದ್ರೆ ಏನ್ ಟೆನ್ಷನ್ ಇಲ್ಲ. ಓಕೆ, ಈ ರೂಲ್ ಏನ್ ಅಪ್ಲಿಕೇಬಲ್ ಆಗಲ್ಲ ಸಿಮಿಟ್ರಿಕ್ ಮಾಲಿಕ್ಯೂಲ್ ಗೆ. ಓಕೆ, ಇಟ್ಸ್ ಹೈಡ್ರೋಜನ್ ಅಯೋಡೈಡ್ H plus and I minus, electronegative gets a negative and electropositive get a positive. Okay, this is a negative part attacks carbon containing least number of hydrogen atom. Okay, so if I give a symmetric molecule ಕೊಡ್ತೀನಿ ಅನ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿ ನೋಡಿ, if it is a CH3 CH double bond CH2. ಈಗ now there is a plane. ಏನ್ ಆಟ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಇದೇನಪ್ಪ ಇದು ಹೈಡ್ರೋಜನ್ ಅಯೋಡೈಡ್ ಅಲ್ವಾ, ಹೈಡ್ರೋಜನ್ ಅಯೋಡೈಡ್. ಸೊ ಈಗ H ಇಲ್ಲಿ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೋ how to find this? So there was a scientist named as a Markovnikov. Okay, this scientist gave a simple rule. ನಮಗೆಲ್ಲ ಈಸಿಯಾಗಿ ಮಾಡ್ಕೊಟ್ಟಿದ್ದಾರೆ. ಏನು ಅಂದ್ರೆ just follow the Markovnikov's rule. ಈ ರೂಲ್ ಫಾಲೋ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಆನ್ಸರ್ ಆರಾಮಾಗಿ ಗೊತ್ತಾಗುತ್ತೆ. ಹೆಂಗಪ್ಪ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ನಾನೇನಂದೆ NaCl. ಏನ್ NaCl ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಪಾರ್ಟ್. ಯಾವ್ದು ನೆಗೆಟಿವ್ ಪಾರ್ಟ್? ಇದು ನೆಗೆಟಿವ್ ಪಾರ್ಟ್ ಅಟ್ಯಾಕ್ಸ್ ಕಾರ್ಬನ್ ಕಂಟೈನಿಂಗ್ ಲೀಸ್ಟ್ ನಂಬರ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಆಟಮ್. ಎಲ್ಲಪ್ಪ ಲೀಸ್ಟ್ ನಂಬರ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇದೆ? ಸೊ ಡಬಲ್ ಬಾಂಡ್ ನೋಡ್ಬೇಕು. ಓಕೆ, ಮತ್ತೆ ದಡ್ರು ತರ ಇಲ್ಲಿ ನೋಡ್ಬಿಟ್ಟಿರಾ, ಇಲ್ಲಲ್ಲ, ಆಲ್ಕಿನ್ಸ್ ನೋಡ್ಬೇಕು ನೀವು. ಓಕೆ, ಆಲ್ಕಿನ್ಸ್ ಅಲ್ಲಿ ಲೀಸ್ಟ್ ನಂಬರ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಎಲ್ಲಿದೆ? ಇದ್ರಲ್ಲಿ ಅಲ್ವಾ ಲೀಸ್ಟ್ ನಂಬರ್. ಇದರಲ್ಲಿ 1 ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇದೆ. ಇದ್ರಲ್ಲಿ ಎಷ್ಟು ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇದೆ? 2 ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇದೆ. ಓಕೆ, ಸೊ ದಿಸ್ ನೆಗೆಟಿವ್ ಪಾರ್ಟ್ ಅಟ್ಯಾಕ್ ಕಾರ್ಬನ್ ಕಂಟೈನಿಂಗ್ ಲೀಸ್ಟ್ ನಂಬರ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಆಟಮ್. ಅಂದ್ರೆ ದಿಸ್ ಅಯೋಡಿನ್ attacks on this carbon atom. This iodine attacks on this carbon atom. Hence, you are getting the CH3 CH single bond CH. Where does it is attacking? This is attacking on a iodide, and you are getting the hydrogen. So write this molecule neatly: CH3 CH iodide and CH3. Fine. So this is how you are getting the final product. Okay, so Markovnikov's rule has a many advantages. Okay, so ನಿಮಗೆ just simple ಆಗಿ ಈ ತರ ರಿಯಾಕ್ಷನ್ ಕೊಟ್ಬಿಟ್ರೆ ಹೇಗೆ ಆನ್ಸರ್ ಮಾಡ್ತೀರಾ? Okay, so you have to follow the Markovnikov's rule. Okay, addition of halogen. Okay, so not only this, ಬರೀ ಹೈಡ್ರೋಜನ್ ಅಯೋಡೈಡ್ ಅಷ್ಟೇ ಅಲ್ಲ. if you take this also Cl2 ತಗೊಳ್ತೀರಾ, ಅವಾಗ ಏನ್ ಮಾಡ್ತೀರಾ, ಎಲ್ಲಿ ಆಡ್ ಮಾಡ್ತೀರಾ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. Okay, that is what how you are going it. Okay, so let me write the reaction now completely. Okay, ಈಗ ರಿಯಾಕ್ಷನ್ ಬರೆಯೋಣ ಯಾವ ತರ ಪ್ರಾಡಕ್ಟ್ ಬಂದಿತ್ತು ಅಂತ. CH3 CH2 double bond CH2. when this react with the hydrogen iodide, ನಿಮಗೆ ಎರಡು ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ. ಅಂದ್ರೆ ಎರಡು ತರನೂ ಬರುತ್ತೆ, ಆದ್ರೆ ಮೇಜರ್ ಪ್ರಾಡಕ್ಟ್ ಯಾವುದು ಅನ್ನೋದು ಮೈನ್ ಫ್ಯಾಕ್ಟರ್ ಆಗುತ್ತೆ. ಮೇಜರ್ ಪ್ರಾಡಕ್ಟ್ ಮಾರ್ಕೋನಿಕೋಸ್ ರೂಲ್ ನ ಫಾಲೋ ಮಾಡುತ್ತೆ. ಫಸ್ಟ್ ಮೇಜರ್ ಪ್ರಾಡಕ್ಟ್ ಬರೀತೀನಿ ನಾನು, CH3 CH iodine and CH3. let me write this hydrogen iodide. ಇನ್ನೊಂದು ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ, ಅದು ಆಂಟಿ ಮಾರ್ಕೋನಿಕೋಸ್ ರೂಲ್ ತರ ಬರುತ್ತೆ. CH2 ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಬರುತ್ತೆ, ಇಲ್ಲಿ iodine ಬರುತ್ತೆ. ಓಕೆ, ಸೊ ದ ಮೇಜರ್ ಪ್ರಾಡಕ್ಟ್ ವಿಲ್ ಬಿ ದಿಸ್. ಇದು ನಮಗೆ ಮೇಜರ್ ಪ್ರಾಡಕ್ಟ್ ಆಗಿರುತ್ತೆ. this will be our major product and this will be our minor product. Okay, ಇದು ನಮಗೆ minor product ಆಗುತ್ತೆ, ಇದು major product. Okay, this is the difference. Okay, this is following a Markovnikov's rule. Okay, this is a Markovnikov's. This is how you can prepare the alkyl halides. Okay, so there is a one more reaction, that is with the same, that is the alkene ತಗೊಳ್ಳೋಣ. I'm taking alkene and treating this with the Br2 in the presence of CCl4 in the presence of carbon tetrachloride. So what you are getting? Just simple addition of a bromine, two bromines to an alkene group. Okay, this is alkene. Okay, so carbon 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 carbon, and you're getting the bromine and you're getting the bromine here. Okay, this is how you can just do it. Okay, so while see when in your exams when you are writing about the any reaction, okay, so reaction ಬರೆಯುವಾಗ ನೀವು ಪ್ರಿಸೈಸ್ ಆಗಿ ನೀಟಾಗಿ ಬರೀಬೇಕು. ಏನು ಅಂದ್ರೆ ಈ ಕಾಂಪೌಂಡ್ ಬಂದ್ಬಿಟ್ಟು ಖಾಲಿ ಬಿಡಬಾರ್ದು. ಯು ಹ್ಯಾವ್ ಟು ನೇಮ್ ದಿಸ್ ಕಾಂಪೌಂಡ್ ಆಲ್ಸೋ. ಓಕೆ, ಯು ಹ್ಯಾವ್ ಟು ನೇಮ್ ದಿಸ್. ವಾಟ್ ಇಸ್ ದಿಸ್? 1 2 3 carbon atoms, so it is called as a prop double bond. It is in which portion there is a double bond? first position, lowest. So prop 1 ene. This is the name of this compound. If you treat prop 1 ene with the hydrogen iodide, it follows a Markovnikov's rule. The major product will be this. What is the major product name? Idru the name model. We have to name one. So 1, 2, 3. So what is this name? It is a this is 2-iodo propane. 2-iodo propane. What about this? It is a 1-iodo propane. 1-iodo propane. Okay. So 2-iodo propane is your major product. Okay, fine. So this is how you can name it. Okay, this is a simple alkane and it is giving you a dibromoalkanes. It is giving you a dibromoalkane, not ene, alkane, dibromoalkane. Okay, this is called as what? I told you something, right? Vicinal dihalide, right? Vicinal alide. So vicinal monohalide ಒಂದ ಇದ್ರೆ so double bond ಗೆ ಈ ತರ ಬಂದಿದೆ. Okay, with it vis dibromo derivative. Okay, vis dibromoid ಇಂದ ಬಂದಿರೋದು. Okay, ನಾನು ಡಬಲ್ ಬಾಂಡಿಗೆ ಹೇಳಿದ್ದೆ ಬಟ್ ಇದರಿಂದ ಬರೋಂತ ಪ್ರಾಡಕ್ಟ್ ನಾವು ವಿಸ್ ಅಂತ ಕರಿಬಹುದು. ಓಕೆ, ಏನ್ ತೊಂದರೆ ಇಲ್ಲ. ಜಸ್ಟ್ ಇಫ್ ಯು ಗೆಟ್ ಕನ್ಫ್ಯೂಸ್ ಜಸ್ಟ್ leave this thing. Okay, leave this thing, don't need to write, just write the IUPAC name. Okay, common name is not necessary, IUPAC is necessary. Okay, so next the last reaction with the halogen exchange. Okay, this is very easy. Halogen exchange reaction. So halogen exchange ಮಾಡ್ತೀರಾ ಅಷ್ಟೇ. So you are having a alkyl halide. Okay, you are taking one alkyl halide. ಸೊ ಆಲ್ಕೈಲ್ ಹ್ಯಾಲೈಡ್ ಪ್ರಿಪೇರ್ ಮಾಡಕ್ಕೆ ಆಲ್ಕೈಲ್ ಹ್ಯಾಲೈಡ್ ತಗೊಂಡಿರಾ. ಏನಕ್ಕೆ ಅಂದ್ರೆ ನಿಮಗೆ ಲೈಕ್ ಯು ಹ್ಯಾವ್ ಹೆಂಗ RCl. ಓಕೆ, ನಿಮಗೆ ಲೈಕ್ ಆಲ್ಕೈಲ್ ಕ್ಲೋರೈಡ್ ಇದೆ, ನಿಮಗೆ ಅಯೋಡೈಡ್ ಬೇಕು. ಅವಾಗ ಏನ್ ಮಾಡ್ತೀರಾ? ಯು ಆರ್ ಟೇಕಿಂಗ್ ಸೋಡಿಯಂ ಅಯೋಡೈಡ್ ಟ್ರೀಟ್ ಮಾಡ್ತೀರಾ. ಅವಾಗ ಏನ್ ಬರುತ್ತೆ? ಯು ಆರ್ ದೇರ್ ಇಸ್ ಅ NaCl ಗೆಟಿಂಗ್ ಔಟ್ ಫ್ರಮ್ ದಿಸ್ ಅಂಡ್ ಯು ಆರ್ ಗೆಟಿಂಗ್ ದ Ri plus NaCl. Okay, this reaction is called as a very important reaction, named reaction. It is a Finkelstein reaction. Finkelstein reaction. Finkelstein was a scientist who gave this reaction. Okay, he was a scientist who found this reaction first time. So on the memory of him, we have kept this reaction name as a Finkelstein reaction. Okay, so you are treating alkyl halide with any halide, with any sodium halides, and you are getting the alkyl halide. You are just exchange the halide here. Okay, ಈ chlorine ನ ಬದಲು you have got the iodide here. Okay, so and there is one more reaction, that is a Schwarz reaction. Schwarz reaction. What is Schwarz reaction? Okay, so ಈ ಮೆಥಡ್ ಅಲ್ಲಿ, in a Finkelstein method, you can only prepare chlorine and bromines and iodines can be prepared here. Okay, this method. But generally fluorine prepare ಮಾಡಕ್ಕೆ we use this Schwarz reaction. Very important reaction, that is very like ಸ್ಪೆಸಿಫಿಕ್ ರಿಯಾಕ್ಷನ್ ಇದೆ. ಓಕೆ, ಸ್ಪೆಸಿಫಿಕ್ ರಿಯಾಕ್ಷನ್ ಏನಕ್ಕೆ ಅಂದ್ರೆ ಇದು ಕ್ಲೋರಿನ್ ಬ್ರೋಮಿನ್ ಅಯೋಡಿನ್ ಎಲ್ಲ ಯೂಸ್ ಮಾಡಲ್ಲ. ನಾವು ಮೈನ್ ಯೂಸ್ ಮಾಡೋದು ಅದಕ್ಕೆ ಫ್ಲೂರಿನಿಂಗ್ ಮಾತ್ರ. ಏನಕ್ಕೆ ಫ್ಲೂರಿನಿಂಗ್ ಅಂದ್ರೆ ಫ್ಲೂರಿನ್ ತುಂಬಾ ರಿಯಾಕ್ಟಿವ್, ಸುಮ್ಮನೆ ನೀವು ರಿಯಾಕ್ಟ್ ಮಾಡಕ್ ಆಗಲ್ಲ ಅದನ್ನ. ಓಕೆ, ಸೊ ಇಟ್ಸ್ ಹೈಲಿ ರಿಯಾಕ್ಟಿವ್. ಏನಕ್ಕೆ ರಿಯಾಕ್ಟಿವ್ ಅಂದ್ರೆ ವೆರಿ ಇಟ್ ಹ್ಯಾಸ್ ಮೋರ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ, ಸಣ್ಣ ಸೈಜ್ ಇದೆ. ಓಕೆ, ಇಟ್ ಹ್ಯಾಸ್ ಮೋರ್ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ. ಓಕೆ, ಮೋರ್ ಅಫಿನಿಟಿ. ಓಕೆ, ಸೊ ಈ ಕಾರಣಕ್ಕೋಸ್ಕರ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಮೋರ್ ರಿಯಾಕ್ಟಿವ್. ಹಾಗಾಗಿ ಇದನ್ನ ಸುಮ್ಮನೆ ಹೆಂಗ್ ಬೇಕಂಗ್ ಯೂಸ್ ಮಾಡಕ್ ಆಗಲ್ಲ. ಸೊ ವಿ ಆರ್ ಟ್ರೀಟಿಂಗ್ ದಿಸ್ ವಿತ್ ನಾರ್ಮಲ್ alkyl bromide and with the fluorinating agents. We are using the fluorinating agents. Okay, fluorinating agents use ಮಾಡ್ಕೊಂಡು ನಾವು we are preparing this fluorine bromide. Okay, we are preparing the alkyl fluorides. I am using a AgF as a fluorinating agents and I am getting the product as a CH3 fluoride and silver bromide. Okay, silver bromide. Okay, what are the fluorinating agents? ಫ್ಲೂರಿನೇಟಿಂಗ್ ಏಜೆಂಟ್ ಅಂದ್ರೆ ಏನು? ಯಾವ ಫ್ಲೂರಿನ್ ಕೊಡುತ್ತೋ ಅದನ್ನ ನಾವೇನಂತೀವಿ? ಫ್ಲೂರಿನೇಟಿಂಗ್ ಏಜೆಂಟ್. ಸೊ ಎಕ್ಸಾಂಪಲ್ಸ್ we can take a silver fluoride and mercuric fluorides, HgF2. We can take a cobalt fluorides. We can take a antimony fluorides. Okay, these are fluorinating agents. Okay, these are all are fluorinating agents. Okay, so this ends your just preparations of alkyl halides. Okay, so I'll just end your section by completing the one more topic, that is the physical properties. What are the physical properties of alkyl halides? In physical properties alkyl halides, okay, alkyl halides are colorless. ಒಂದೇನು ಅಂದ್ರೆ these are colorless. these are colorless. Okay, next ಇನ್ನೊಂದೇನು ಅಂದ್ರೆ ಬ್ರೋಮೈಡ್ಸ್ ಮತ್ತು ಅಯೋಡೈಡ್ಸ್ ಇದೆಯಲ್ಲ, they develop a color when exposed towards the light. Okay, so this bromides, alkyl bromides, that is, let me take a R bromides or R iodides, when exposed towards the light, H nu, it shows a color. It shows a color. Okay, it shows a color, and they having somewhat a sweet smell. Okay, ಸ್ವಲ್ಪ ಸಿಹಿಯಾದ ಸುಗಂಧ ಇರುತ್ತಂತೆ. Okay, it has a very sweet smell. Okay, what about the melting and boiling point? ಮೆಲ್ಟಿಂಗ್ ಅಂಡ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಏನಾಗಿರುತ್ತೆ? ಜನರಲಿ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಮತ್ತೆ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಹೇಳೋದಾದ್ರೆ, ಆಸ್ ಮಾಸ್ ಇನ್ಕ್ರೀಸ್ ಆದ್ರೆ ವ್ಯಾಂಡ್ರವಾಲ್ ಫೋರ್ಸ್ ಕೂಡ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ವ್ಯಾಂಡ್ರವಾಲ್ ಫೋರ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆದ್ರೆ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂಡ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ increases. Okay, melting point and boiling point increases. Okay, if you write order for an halides, so if you write iodide and bromide, and if I write R chlorides and R fluorides, ಯಾವ್ದಕ್ಕೆ ಮಾಸ್ ಜಾಸ್ತಿ ಇದೆ? Obviously for iodides, next for bromides, next chlorides, next chlorides. So the one which is having a higher mass will be having a more van der Waals force and dipole interaction. What is dipole interactions? Idru madhye, I'll tell you what is. First idu nodi, this is having a greater boiling point. Okay, this is the order of boiling point and melting point both. Okay, so now I'll talk about what is dipole interaction. Dipole interaction ಹೇಗಿದೆ ಇದರಲ್ಲಿ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, when you take a R and a iodide and one more R and iodide, if you say like if you are taking like 2 ml of alkyl halide ತಗೊಂಡಿರಾ ಅಂದ್ಮೇಲೆ, so this is having somewhat liquid, right? This are like if you take liquids, there's a 2 ml of liquid ತಗೊಂಡಿದ್ರೆ ಎಷ್ಟು alkyl halides ಇರುತ್ತೆ? Like it has a Avogadro number of alkyl halides, right? ಅದೇ ತರ ಎಷ್ಟೊಂದು alkyl halides ಇರುತ್ತೆ ಇಲ್ಲಿ. Okay, due to interaction there is a polarity right here. ಇದಕ್ಕೆ ಪಾಸಿಟಿವ್, ಇದಕ್ಕೆ ನೆಗೆಟಿವ್, ಇದಕ್ಕೆ ಪಾಸಿಟಿವ್, ಇದಕ್ಕೆ ನೆಗೆಟಿವ್, ಇದಕ್ಕೆ ಪಾಸಿಟಿವ್, ನೆಗೆಟಿವ್. So these type of interaction between them. Okay, so let's sorry, between these molecules there is somewhat the interaction present here. Okay, there's an interaction due to the difference in the charges here. Okay, ಈ charge difference ಇರೋದ್ರಿಂದ there is somewhat interaction. Okay, dipole ಇವೆರಡು dipoles ಇದು dipoles this interaction dipole interaction. Okay, as a dipole ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, their boiling point melting point increase ಆಗುತ್ತೆ. As a mass increases, even this also increases. Okay, this is a one thing. Next, one more thing, ಸೇಮ್ ಈಗ ಬ್ರಾಂಚ್ಗೂ ಮತ್ತೆ ಲೀನಿಯರ್ಗೂ ಕಂಪೇರ್ ಮಾಡಿ ಏನಾಗುತ್ತೆ, ಫಾರ್ ಅ ಬ್ರಾಂಚ್ಡ್ ಆಲ್ಕೈಲ್ ಹ್ಯಾಲೈಡ್ಸ್ ಅಂಡ್ ಫಾರ್ ದ ಲೀನಿಯರ್ ಆಲ್ಕೈಲ್ ಹ್ಯಾಲೈಡ್ಸ್ ಯಾವ್ದಕ್ಕಿರುತ್ತೆ? ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ ಕೊಡ್ತೀನಿ. ಏನು ಅಂದ್ರೆ, ಈಗ ಒಂದು ಪಾತ್ರೆ ತಗೊಂಡಿರಾ, ಓಕೆನಾ? ಸೊ ಪಾತ್ರೆ ಬೇಡ, ಇಲ್ಲಿ ಸಿಂಪಲ್ ಆಗಿ ಒಂದು ತವಾ ತಗೊಳ್ಳಿ, ಲೈಕ್ ಸ್ಟಿಲ್ ಲೈಕ್ ಎನಿ ಪ್ಲೇಟ್. ಓಕೆ, like any plate. Okay, we took any tawa here. Okay, maybe this is somewhat tawa. Okay, so I'm just adding a liquid here. Okay, this is a simple liquid. Okay, a simple liquid. This is having somewhat just density. And the same liquid, other liquid linear shape ಅಲ್ಲಿ ಇರುತ್ತೆ. Okay, same liquid having a linear means ತುಂಬಾ ಉದ್ದ ಇರುತ್ತಾ? ತೆಳುವಾಗಿರುತ್ತೆ, but it's not a very bigger. Okay, it's having a linear shape. Okay, so if you try to eat this, ಇದನ್ನ eat ಮಾಡಿ, if you eat this, okay, it is a branch. I'll write the branch here. Okay, so carbon, halogen, carbon, halogen. ಸರ್ಫೇಸ್ ಏರಿಯಾ ನೋಡಿ, ಇಲ್ಲಿ ಇದ್ರ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಎಷ್ಟಿದೆ, ಇದ್ರ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಎಷ್ಟಿದೆ, ಯಾವ್ದು ಸರ್ಫೇಸ್ ಏರಿಯಾ ಜಾಸ್ತಿ ಇದೆ, that will be having a more boiling point. Simple. ಇದನ್ನ ಈಟ್ ಮಾಡಕ್ಕೆ ಎಲ್ಲಾ ಕಡೆಯಿಂದ ನೀಟ್ ಸಪ್ಲೈ ಮಾಡ್ಬೇಕಾ? ಸೊ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ದೆನ್ ಇಟ್ ಗೆಟ್ ಎವಾಪರೇಟೆಡ್. ಬಟ್ ಇಲ್ಲಿ ಈಟ್ ಮಾಡಕ್ಕೆ ಜಸ್ಟ್ ಮೈದಲ್ಲಿ ಸಪ್ಲೈ ಮಾಡಿದ್ರೆ ಸಾಕು, ಯು ಜಸ್ಟ್ ಗೆಟಿಂಗ್ ಎವಾಪರೇಟೆಡ್ ಫಾಸ್ಟರ್. ಓಕೆ, ಸೊ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಲೆಸ್ಸರ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂಡ್ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಮೋರ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ಜಸ್ಟ್ ಅ ಡಿಫರೆನ್ಸ್. ಓಕೆ, ಇದರಲ್ಲಿ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ದ ಸರ್ಫೇಸ್ ಏರಿಯಾ. ಸರ್ಫೇಸ್ ಏರಿಯಾ ಜಾಸ್ತಿ ಇದ್ರೆ ಅದಕ್ಕೆ ಜಾಸ್ತಿ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಇಲ್ಲ, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇರುತ್ತೆ. ಓಕೆ, ಇಫ್ ಐ ಟಾಕ್ ಅಬೌಟ್ ದ ಅರೈಲ್ ಹ್ಯಾಲೈಡ್ಸ್ ಬಗ್ಗೆ ಮಾತಾಡಿದ್ರೆ ಲೈಕ್ ಆರ್ಥೋ ಪ್ಯಾರಾ ಅಂಡ್ ಅ ಮೆಟಾ. ಆರ್ಥೋ ಪ್ಯಾರಾ ಮೆಟಾ ಬಗ್ಗೆ ಮಾತಾಡಿದ್ರೆ ಏನಾಗಿರುತ್ತೆ ಇಲ್ಲಿ? ದಿಸ್ ಇಸ್ ಆರ್ಥೋ and this is a meta and this is a para dihalides. Okay, so ಇಲ್ಲಿ ನೋಡಿ. ಸೊ ಇದರಲ್ಲಿ ಯಾವ್ದಕ್ಕೆ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಮತ್ತೆ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ? ಫಾರ್ ವಿಚ್ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಆರ್ ಅ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ವಿಲ್ ಬಿ ಗ್ರೇಟರ್? ಯಾವುದಕ್ಕೆ ಅಂದ್ರೆ ಯಾವುದು? Okay, so I'll just take this example in here, okay, because I'll show you correctly. ಎರಡೆರಡು ಮಾಲಿಕ್ಯೂಲ್ ಒಟ್ಟಿಗೆ ಇದ್ರೆ ಹೇಗಾಗುತ್ತೆ? If two molecules become closer, are they packed very well? ಇಲ್ಲಿ ಪ್ಯಾಕಿಂಗ್ ಚೆನ್ನಾಗಿ ಆಗ್ತಿದೆಯಾ? ಇಲ್ಲಿ ನೋಡಿ, ಪ್ಯಾಕಿಂಗ್ ಚೆನ್ನಾಗಿ ಆಗ್ತಿದೆಯಾ ಇಲ್ಲಿ? ಇನ್ನೊಂದು ನೋಡಿ ಇಲ್ಲಿ. Let me take the para in this case. Cl. And join agila, just I'm joining here. Okay, this is break here, but they're so close here. Okay, this has break. These are very closer. Okay, that's what I'm talking here. Chlorine, like this. So these are not joined. Okay, just remember, these are not joined. They are just closer here. Okay, closer here. See, these are very closer. Tumba hatra idea. Like there's a very like attracted more here. Okay, more attracted. Okay, these are having a good crystals when it solidifies. And solidify ಆದಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ತುಂಬಾ ಚೆನ್ನಾಗಿ solidify ಆಗುತ್ತೆ, ಏನು ತೊಂದರೆ ಇಲ್ದಂಗೆ. ಓಕೆ, ಎಲ್ಲ ಹತ್ರ ಕೂಡ್ಕೊಂಡಿರುತ್ತೆ. ಓಕೆ, ಸೊ when you eat this ತುಂಬಾ ಜಾಯಿನ್ ಇರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, you need to eat up more. ಆದ್ರೆ ಇದು ಎಲ್ಲ ದೂರ ಇದೆ ಅಲ್ವಾ, ಸೊ you can evaporate it faster. ಓಕೆ, ಇದನ್ನ ನೀವು ಬೇಗ evaporate ಮಾಡಬಹುದು. ಸೊ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಲೆಸ್ಸರ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂಡ್ ಅ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್. ಬೇಗ ಆವಿ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಏನರ್ಥ? ಆಲ್ಕೋಹಾಲ್ಸ್ ಇದೆ ಅಲ್ವಾ, ಆಲ್ಕೋಹಾಲ್ಸ್ ಲೈಕ್ ಸ್ಯಾನಿಟೈಸರ್ ಇದೆ ಅಂತ. ನಿಮ್ ಸ್ಯಾನಿಟೈಸರ್ ಕೈಗೆ ಹಾಕೊಂಡು ಸುಮ್ಮನೆ ಹಿಂಗ್ ಉಚ್ಕೊಂಡ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ? ಆವಿಯಾಗಿ ಹೋಗುತ್ತೆ ಅಲ್ವಾ. ಸೊ ವಾಟ್ ಇಸ್ ದ ರೀಸನ್? ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಲೆಸ್ಸರ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇದೆ. ಓಕೆ, ಅದಕ್ಕೋಸ್ಕರ ಏನಾಗುತ್ತೆ? ಬೇಗ ಆವಿ ಆಗುತ್ತೆ. ಬಟ್ ವಾಟರ್ ಹಾಕೊಂಡಾಗ ಮಾಡಿದ್ರೆ ಬೇಗ ಆವಿ ಆಗುತ್ತಾ? ಇಲ್ಲ, ಬಿಕಾಸ್ ವಾಟರ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಮೋರ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್. ಸೇಮ್ ಇನ್ ದಿಸ್ ವೇ ದಿಸ್ para is having a more boiling point. Reason is these are very close to each other and they having a good crystal lattice. Okay, so having a good crystal lattice. But ಇಲ್ಲಿ ನಿಮಗೆ ಸ್ಪೇಸಿಂಗ್ ತುಂಬಾನೇ ಇರುತ್ತೆ. ಓಕೆ, ಯು ಹ್ಯಾವ್ ಅ ಸ್ಪೇಸ್ ಹಿಯರ್, ಸ್ಪೇಸ್ ಇಲ್ಲಿ ಸ್ಪೇಸ್ ಇದೆ. ಇಲ್ಲಿ ನೋಡಿ ಎಷ್ಟು ಹತ್ರ ಇದೆ ಇಲ್ಲಲ್ಲ ಅಲ್ವಾ. Okay, so to boil this you need a higher temperature, to boil this you need a lower temperature. So this ortho, okay, so among this is having a, like if I talk about the boiling point here, it is having a 453. Okay, it's having a 453. So let me take a melting point. Okay, it is having a almost a 256. Okay, and this is having a 249. Okay, and this is having a 320. Okay, you can see the observation here, right? See, aduk ಜಾಸ್ತಿ ಇದೆ. This is having a more because it is having a crystals are very easily. Next, about the density. If I talk about the density, so density is directly proportional to the molecular mass. Molecular mass yaduk ಜಾಸ್ತಿ ಇರುತ್ತೋ that is having a more density. Simple. Okay, so if I give example, like if I talk about NC3H7 chloride, okay, it is having a density of 0.89. Okay, 0.89. And if it is C3H7 bromine, it is having density of 1.335. Okay, yadu density ಜಾಸ್ತಿ ಇದೆ. Density ಇದಕ್ಕೆ ಅಲ್ವಾ, ಏನಕ್ಕೆ? Because the bromine is a more weighter. ಜಾಸ್ತಿ weight ಇದೆ ಅಲ್ವಾ bromine ಗೆ, it has more molecular mass. Chlorine ಗೆ lesser molecular mass. So density is directly proportional to the molecular mass. Okay, so next is the solubility. ಅದು ಹೇಗೆ ಸಾಲ್ಯುಬಲ್ ಆಗುತ್ತೆ ಅಂತ. ಸೊ ಯಾವ್ದ್ರಲ್ಲಿ ಸಾಲ್ಯುಬಲ್ ಆಗುತ್ತೆ ಅಂತ. ಓಕೆ, ಸೊ ಜನರಲಿ ರಿಮೆಂಬರ್ ಇನ್ ಆರ್ಗಾನಿಕ್ ಥಿಂಗ್ಸ್, organic compounds are less polar, or you can directly tell it as a non-polars. Okay, non-polars. Okay, so always like dissolves in a like ಅಂದ್ರೆ ಪೋಲಾರ್ ಕಾಂಪೌಂಡ್ಸ್ ಗಳು ಪೋಲಾರ್ ಅಲ್ಲೇ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ, ನಾನ್ ಪೋಲಾರ್ ಕಾಂಪೌಂಡ್ಸ್ ಗಳು ನಾನ್ ಪೋಲಾರ್ ಅಲ್ಲೇ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಲೆಸ್ ಪೋಲಾರ್ ಆಗಿರ್ತವೆ ಆರ್ಗಾನಿಕ್ ಕಾಂಪೌಂಡ್ಸ್ ಗಳು, ಇಲ್ಲ ನಾನ್ ಪೋಲಾರ್ ಆಗಿರ್ತವೆ. ಸೊ ಮೋರ್ ಪೋಲಾರ್ ಇರೋ ಚಾನ್ಸೇ ಇಲ್ಲ. ಓಕೆ, ಸೊ ವಾಟರ್ ನೋಡಿ, Water is not organic. It's not an organic, right? ಇಲ್ಲಿ ಕಾರ್ಬನ್ ಹೈಡ್ರೋಜನ್ ಏನಿಲ್ಲ, ಹೈಡ್ರೋಕಾರ್ಬನ್ ಅಲ್ಲ ಇದು, ಸಿಂಪಲ್ ಹೈಡ್ರೋಜನ್ ಮತ್ತು ಆಕ್ಸಿಜನ್ ಅಷ್ಟೇನೆ. ಓಕೆ, ಸೊ it is polar. But this is, what about this organic compound like haloalkanes? These are less polar. Okay, let me write those things. Okay, so haloalkanes are only slightly soluble in water. ಏನಕ್ಕೆ ಅಂದ್ರೆ these are having a less polarity. Okay, these are having a less polarity. This is having a more polarity. Okay, this is the reason why they are why they are difficultly soluble in the water. Okay, but they are soluble in a benzene, toluene, ethers, because these are all organic solvents. Okay, fine. So at the last, I'm ending the section. So I will ask you one last question. So you can just answer it in a next class. Okay. So what happens when you treat this group CH2OH with HCl? What is the product you are getting? You are just eating it. What is the product you are getting? And one more reaction. What is this? When you treat cycloalkene in Br2, or let me change this. Treat this with this compound. I give HBr. So what will be the reaction you are getting? Just eat it with a UV light. What is the products you are getting? Take this as your assignment today. Okay, just try to do this. Any idea? So what you can get here? Okay, students, try to do this assignment. Okay, and I'll continue the remaining topics, that is chemical reactions of the haloalkanes and haloarenes, in the next section. Okay, thank you so much. Have a nice day.